Earlier this year, I pulled the real Deep Space Network recordings of Cassini's final morning out of NASA Public Archive and rebuilt the last minutes of its radio carrier from the station's own measurement files. What you are about to hear is that carrier, rendered from the archived data. Its strength follows the logged receiver power, its pitch the tracked frequency. Here is the end of Cassini as the dish measured it. The part that still gets me is this. That tone died at 11:55 and 46 seconds, Universal Time, on 15 September 2017. Saturn was so far away that the radio waves needed 83 minutes to reach us. When the control room heard the end, the spacecraft had already been gone for nearly an hour and a half. And the second thing, NASA had destroyed it on purpose. Cassini was still working, still sending home science. When the agency flying it steered it into the planet it had studied for 13 years. Why kill a healthy spacecraft at the top of its game? The morning played out between one room in California and some large antennas in Australia. NASA Deep Space Network is the set of giant dishes, spread across 3 sites, so a spacecraft is always above one. That day, a 70-meter dish near Canberra carried the link, with a 34-meter dish as backup and a European station on the carrier. For 20 years, Cassini recorded its data and sent it home later. On its last day, the team made it a live relay, streaming measurements home seconds after taking them at 27 kilobits a second, about dial-up speed. 8 of the 12 instruments were on, the cameras were off, because pictures cost more bits than that thin line could carry. The dive was a fight, and the records let us replay it second by second. About 900 kilometers above the cloud tops, the atmosphere began to push, and the spacecraft answered with its steering thrusters, holding the antenna on Earth, first gently, then at full power. It kept that line for 91 seconds. The telemetry, the actual measurements, vanished first. The bare carrier outlived it by 24 seconds, flickered once as an antenna side lobe swept past, and went flat. Julie Webster, the spacecraft's operations manager, said it herself afterward. No, it wasn't a comeback. The predictions had the end coming half a minute earlier. Then, at 4:55 and 46 seconds in the morning in California, she made the call.
Okay, we call loss of signal at 115546.
I hope you're all as deeply proud of this amazing accomplishment. Congratulations to you all. This has been an incredible mission, an incredible spacecraft, and you're all an incredible team. I'm going to call this the end of mission. Project manager off the net.
The reasons are concrete, and there are two. Fuel came first. Cassini launched with 565 pounds of propellant. After 2 decades of steering, 61 remained, so the tank was as good as empty. The second reason is the one people rarely hear. 2 of Saturn's moons had turned out to be places where life might start. Enceladus, with an ocean of liquid water under its ice, and Titan, with chemistry resembling a young Earth's. Look, a dead Cassini left drifting could have wandered into one of them someday, seeding an ocean we had only just discovered with stowaway Earth microbes. Nobody was willing to risk that. Honestly, the decision only makes sense when you see the alternatives. NASA genuinely weighed parking Cassini in a stable orbit and switching it off. The leftover fuel could have stretched operations a few more years at much lower science value. A parked Hulk stays a collision risk forever. The mission's own evaluations checked against international planetary protection standards, kept pointing one way. Saturn itself would be the grave, and its atmosphere guaranteed a complete ending. The spacecraft would burn up like a meteor, and anything surviving would sink deep into a planet with no conditions favorable to life as we know it. One myth to bury here: the internet sometimes says Cassini was killed to save money. No NASA document supports that. The ending mattered because the mission almost didn't fly. Cassini left Cape Canaveral on 15 October 1997 aboard a Titan 4B rocket, carrying 3 nuclear power sources with about 71 pounds of plutonium dioxide, the material that kept it powered. The protests were real and sizable. A campaign called Stop Cassini drew some 1,500 people to the Cape that May, and 11 days before launch, 27 people were arrested at the gate. Safety reviews ran as high as the White House Science Office. The government's own environmental statement concluded that even a launch accident releasing the fuel was not expected to add 1 cancer death. Then the rocket lit in the dark and climbed. Getting to Saturn took 7 years and 2 billion miles, looping past Venus twice, then Earth, then Jupiter. On 30 June 2004, the main engine burned for 96 minutes while the spacecraft passed through a gap in the rings, and at 9:12 that evening, the control room erupted. Cassini was the first machine to orbit Saturn. 6 months later, it released a European-built probe called Huygens toward Titan, still the only place a craft from Earth has landed in the outer solar system. Huygens fell through the haze for nearly 2.5 hours, then radioed from the surface for 72 minutes, until Cassini, its only relay, dropped below the horizon. Remember that mechanic. The mission's first goodbye rehearsed its last. The discovery that rewrote the mission came in 2005 at a small icy moon called Enceladus. Images taken that November, backlit by the sun, showed fountains rising from the South Pole, geysers fed by liquid water under the ice, venting through fractures more than 100 kilometers long. A frozen moon had become one of the most promising places we know to look for life. The mission was never the same afterward. The totals give the scale: 293 orbits of Saturn, 162 close flybys of moons, more than 450 000 images, and nearly 4,000 science papers. April 2017 opened the last chapter. One final close pass of Titan reshaped the orbit into weekly dives through the gap between Saturn and its rings, a 2,000-kilometer slot no spacecraft had ever entered. Cassini went in 22 times, and on the first dives it flew antenna first, using the big dish as a shield in case ring dust filled the gap. The dust was largely absent. The gap turned out nearly empty, puzzling the scientists and relieving the engineers. On 8 September, the 22nd dive ended cleanly. 3 days later, a distant flyby of Titan, the goodbye kiss, as the team called it, bent the orbit into a collision course, and Cassini no longer had the fuel to leave it. Here I get to correct the most shared image of the ending. You may have read about Cassini's last photograph as if it showed the plunge. It was taken the evening before 1959 Universal Time on 14 September from 634,000 kilometers out. It looks at Saturn's night side, lit only by sunlight scattered from the rings, toward the spot where the spacecraft would go in, about 8 hours later. There are no photographs of the plunge itself. The thin live link could not carry pictures, and the team chose measurements over postcards. The last thing Cassini sent was data, the composition of Saturn's air, sampled as it fell, and finally a bare radio tone holding on alone. Then there is the part I care about most, the signal itself. On the final morning, Saturn sat about 1 49 billion kilometers away, and radio waves, moving at light speed, needed 83 minutes to cross it. Every screen in that room showed something that had already happened. Nobody anywhere watched Cassini die live. The link was a radio tone near 8.4 gigahertz, arriving almost unbelievably faint. A contractor for the network once put a number to it, as weak as a billionth of a milliwatt, more than 20 billion times less than a digital watch needs an estimate to be fair, but it sets the scale. NASA pointed a 70-meter dish at the end. Months earlier, a British amateur with a home-built 2.4-meter antenna had copied the same carrier. Which brings me back to the archive, because the receivers wrote it all down. The files record the carrier's strength every 5 seconds, the tracking loops lock status, and the frequency the dish followed, all time-stamped. In that data, the end arrives early. The strength starts to slide around 11:55:20. It collapses over the next 20 seconds until the loop reports itself out of lock at about 11:55:44. Webster's 11:55:46 call sits right inside that measured transition, and the second, lower frequency tone held about 5 seconds longer, exactly as NASA-owned display shows. Watching a number I had only read about resolve into a measured curve is when this stopped being history for me. So what is left of Cassini? A planet with slightly more metal in it, and 2 small moons kept clean on purpose. Enceladus still vents its ocean into space. Titan still keeps its chemistry under the haze, both as untouched as the planners could make them. Linda Spilker, the project scientist, said the team takes comfort knowing part of Cassini will always be up there with Saturn. I keep returning to something plainer. A machine we built worked for 20 years, 1.5 billion kilometers from the nearest person who could fix it, and in the end, we gave it up so 2 promising worlds would stay unspoiled. Something will go back someday. The ocean worlds are still waiting, exactly as we left them, and frankly, that feels right.